Okay, so where are we going with all of this? Well, we're going to use if-else statements. And in if-else statements, if an expression is true, then statement 1 is executed. If it's not true, statement 2 is executed. Okay? So something's true, we go through if expression 1 is true, statement 1 is executed. If it is not true, statement 2 is executed. Just going to write here, expression is false. Okay, so here's a couple of examples. Or here's one example. So in here, I have x becomes 2, y becomes 4. So if 2 is greater than 4, if 2 is greater than 4, x plus plus. But in this case, 2 is not greater than 4. So the only thing that gets executed here is y. So a lot of times I'm going to set up, this is how I like to do these. I set up like x and y, a little table, and 2 and 4. And that way, when I have y plus plus, I still know that 2 didn't change, but y became 5. Because a lot of times they'll ask you, like, well, what is the final... well, it's a good way to trace your code, first of all. Or in a multiple choice question, they'll ask you, what are the final values of x and y? And so this table is really easy to help you keep track of those things. All right, sometimes we don't need an else condition. Then we just leave the else out, and we can just say if expression statement 1. If it's not true, if expression 1 is not true, it skips over statement 1 and it keeps going. We also have what's called compound statements. Oh, I don't think I mentioned this before. Just so that we're clear, there are no semicolons here after the parentheses. If we put a semicolon there or here, we're basically telling if it's true, do nothing. Else do nothing. So we want to make sure not to put semicolons in there, only inside with these statements. When I turn this into a PDF, this statement 2 kind of moved to the left. Usually it's in line with the rest of them. But when I use compound statements, and this is important, so meaning I want more than one thing to be done. I want more than one thing to be done when something's true. Okay? When something's false. What I need is these curly braces. These curly braces say, do everything inside in between the curly braces if the expression is true. If the expression is false, do everything inside the else block. We also have what's called nested if-else statements. Sometimes I prefer to use the curly braces. For me, it just makes things more clear. But you will see them without the curly braces. So I'll put curly braces here to make it easier. But you need to know if they're not there, which a lot of times on the test they won't be to trick you. The else, and we can have what's called a dangling else, okay? The else is paired with the closest if. So this else is paired with this if, and then this, since this one's already paired, this else gets paired with this if. If this else was not there, this is what's called the dangling else. This else with statement 2 gets compared with the if that's closest to it. We always start from the inside and work out. In this case, we'll have, here's another nested if-else statement. We could have if expression 1, if expression 2, do statement 1, okay? Else, do something else. That means these both have to be true in order for this to work, because if this is false, it'll go to statement 2. If this is true, it'll go in here. If this is true, if expression 2 is true, it will not do statement 1, and it will not do the else. It'll go all the way outside, so it'll do nothing. That's something to be careful of. So I'm going to write that here. If expression 1 is true, but expression 2 is false, the else statement gets skipped. And we move on. So we're going to move on to the next line of code here. In this case, where we have this, we can't do the same if there's an else statement in either of these. So if we have an if and an if that are nested, and we have no else statements at all, okay, then we can turn them into if this is true and this is true, statement 1, okay? But be careful. You cannot have an else statement here. So I'm going to write, be careful, no else's allowed here. If we had an else, it would not follow the path that we would want it to follow. So if we had an else connected to this if, it would still just be connected to both here. Same thing if we had an else connected to this if, it would still be connected to both here. So just be careful. You can use this, but you don't want any else's connected. We also have what's called multi-way selection. Okay, if we have more than one option to test, we can use else if here as well. And you can have as many of these as you want, which is why I wrote ... I can put more else ifs are okay. So if this is true, I'm going to do statement 1 and 2. Else if this is true, I can do statement 4 and 5. Else if this is true, I can do more and more and more and more else. This last statement. You'll see this in the lab called taxes, where we have like different tax brackets that we're going to be doing, and there's lots of different tax brackets, so we'll probably want to use a bunch of else ifs. Okay? We can omit the last else if there's no default. So if there's no default, you can just skip it. So this is completely okay. Just if, else if, else if. Actually, this one should say expression 3, because you do need to have an expression here. But you can skip it if there's no other. You can skip the else if there's no default statement. All right. So I'm going to do one last note here, which is you want to try and use variable names that are more English-like. So instead of naming a variable X, try done or legal or like, I don't know, what would we use for, I don't know, paid. We want to use something that connects to the problem so we understand what we are searching for. And what are we testing? I've included some information about the switch statement. This is, not tested, but a lot of people like to use it, so I wanted to include it. So there are situations when a program has to take one of several actions depending on the value of some variable or expression. Switch statement makes this happen really easily. Okay? It's not like a loop. Which I don't think it talks about later, but it's not like a loop where it can do things over and over and over again. It literally goes through here once and executes according to whatever is happening. So it'll say switch expression. So this is the expression. You're trying to match an integer, a string, or a char value of the expression with one of the cases down here. And depending on which command is chosen, the program will select one out of many. So like, I don't know, let's say it was like if grade is A. If grade is A, maybe it'll print out, it'll do some stuff and it'll print out, great job. And then it'll break. We need that break there, okay? If it's B, then it will print out something else. Like, so it goes on. And then there's a default, like if there was, I don't know, maybe it'll say, you didn't enter a valid grade here because that would be the default. So here's some common errors. They can't compare double values. It's got to be a string or an int or a char. If your statement is a string, it will be compared as if you're using dot equals, not equals equals, to be clear. So It's comparing their contents. They're not loops. Once they find a case and execute it, they exit. Okay? But you want to put a break statement here. So see, here's break statements. Break statements pop you out of whatever brace you're in. So in this case, these braces is going to pop us out of the switch statement. If you don't use a break, all the cases after the matching case are going to be executed until another break. So that's why it's important that you want to use your break. Okay, so an example here. If you want to write a switch statement that will take an integer from 1 to 7 and print out the corresponding day. I don't think I have enough room here. Let me see if I can do this. Let 1 represent Monday. So let's say, let's use our little test here. That way, if I make a mistake, it'll help me catch it. So we'll just comment all of this out, which is what we tested before. And we'll create our scanner object. So import java.util.scanner. And then we'll say scanner then becomes new scanner. And then we'll say system.in. And then we'll say int x becomes in.read int. And then we'll say, next int. See, I knew it was better to code here, just in case I made an error. Okay, and then let's say switch x. And we'll say case 1. And then we'll say, I didn't want case 1. Case space 1. So if they type in 1, I'm going to write system.out.println Monday. But remember, I want my break statement there, so I'm going to put break. And then I'm going to do this again, but I am going to copy and paste. So now, if it's 2, I want Tuesday. If it's 3, I want Wednesday. If it's 4, I want Thursday. All the way till I get to 7. Now, in this case, maybe I want a default, in which case, maybe I'll put system.out.println you did not enter a valid number. Oh, and I probably should ask them. System.out.println. Otherwise, I'm not going to know what to enter. Or .print. No, let's do line. Please enter a number from 1 to 7. All right. I need a semicolon here and a semicolon here. So let's watch this run. We'll run it a couple different ways. So let's say I type in 1, I get Monday. Great. Let's say I type in an invalid number. So let's say I type in 0. Oh, it says you didn't enter a valid number. That's why it's nice to have a default. We talked about sometimes it won't have a default. I like having a default, but let's say we didn't have a default. We should expect it to print nothing because we won't reach it. So if we don't have a default, it'll print nothing. So I'm going to Command Z so that I get my default back. That's just an example of how the switch statement works. Again, you won't be tested on this, but it is kind of nice to have. And if you decide to use it on the test, you are more than welcome to use it. They do recognize it. So it's something that you can use if you would like to.